Have you ever heard a headline so strange you had to stop and ask, wait, what? A massive hole under North America. Not a sinkhole, not a cave, something far deeper, far older. Beneath the soil, beneath the bedrock, beneath the crust itself. Scientists have found an enormous anomaly, a region where part of the continent's ancient core is literally disappearing. But here's the twist. There's no empty void, no cavern waiting to swallow towns. Instead, the rock itself, rock that's been there for billions of years, is dripping away into the mantle, as if North America is slowly melting from the bottom up. And the real shock? It's the echo of an ancient battle, a geological war that started over 150 million years ago and is still quietly playing out beneath our feet. Stick around, because this story starts with the fall of a continent's shield and the ghost of a plate that refuses to die. The ghost in the mantle. To understand what's eating away at North America from below, we have to travel back to the time when the dinosaurs still ruled the Earth. The supercontinent Pangaea was breaking apart, and a giant oceanic plate, the Farallon Plate, was sliding under North America. This wasn't your average subduction. Other times, it slid in almost flat, scraping under the continent's crust like a knife under toast. This flat slab subduction pushed mountain building far inland, creating ranges like the Rockies, mountains hundreds of kilometers from the coast, in places no one expected them. But every battle has an aftermath. As the Farallon was forced deeper, it began to fragment. Pieces broke off. Some sank into the lower mantle. And those bones are still there, still influencing the living geology of the continent today. Seeing the invisible. For decades, the Farallon Plate was a ghost story for geologists. Everyone knew it had been there. That changed with seismic tomography, Earth's equivalent of an MRI scan. By studying the way earthquake waves travel through the planet, scientists can create 3D maps of the mantle. Cold, dense rock from old oceanic plates makes seismic waves move faster, leaving behind a signature, a kind of fossil fingerprint. Scans have revealed a remarkable geological discovery beneath California's Central Valley, the Isabella Anomaly, a massive, slab-like structure believed to be the long-lost remnant of the ancient Monterey microplate. Even more intriguing, further south beneath Baja California, researchers detected another hidden fragment, this one tied to smaller tectonic plates such as Guadalupe and Magdalena. These weren't dead relics, they were players, and one of their moves was attacking the North American craton, the ancient, stable heart of the continent. The shield starts to fail. A craton is like a continental shield, billions of years old, incredibly thick, and strong enough to resist most geological change. It's what makes places like the Canadian Shield so stable while the edges of continents are torn by earthquakes and volcanoes. But the seismic maps showed something shocking. Parts of North America's craton, deep beneath the US Midwest, were thinning. The base of the continent was literally dripping into the mantle below. Imagine honey hanging from a spoon. Slow, heavy, and inevitable. That's what was happening, but on a scale of hundreds of kilometers and over millions of years. This wasn't erosion from above. It was attack from below. The dripping rock. So how does rock drip? The answer lies in the strange dance between the craton and the Farallon's ghost. Even though the old slab sits nearly 600 kilometers away, it's still cold and dense enough to influence mantle flow. Like a stone in a river redirecting the current, it forces hot mantle material to shear past the underside of the craton. Over time, that flow wears it down, pulling pieces away and sending them sinking deeper into the earth. To make matters worse, as the Farallon's remains slowly heat and release fluids, they weaken the craton's base, turning once rigid rock into something pliable, ready to tear and drip. For the first time in history, scientists weren't just theorizing about this process. They were watching it happen. Slow motion apocalypse. Or natural breathing. Here's the good news. If you were imagining the continent suddenly collapsing like a rotting floorboard, you can relax. This hole beneath our feet isn't about to open up and swallow cities. The process moves on geological time, measured not in election cycles or even centuries, but in millions of years. If you stood in the middle of the Midwest today with a ruler, you wouldn't notice any change at all. But that doesn't make the finding trivial. The discovery matters because it's a reminder that even the most stable, ancient parts of our planet aren't eternal. The shield can fail. The core can melt. It's a quiet but humbling truth. Earth is not a static stage on which history plays out. It's an active, restless machine, constantly reshaping itself on timescales far beyond human lifespans. The same forces that slowly pull apart continents and close oceans are still working under our feet. Silent, patient, and unstoppable. We may not see their full effects for ages, but they will shape the future long after our cities are dust. Not all sinking is equal. Now, here's where the story takes a turn most headlines miss. There's a big difference between what's happening deep beneath the Midwest and the kind of sinking you can see at the surface. When we think of land sinking, we picture cracked roads, tilted buildings, flooded neighborhoods. But that's surface-level subsidence, and it's caused by very different forces. Some are natural. After the last ice age, massive ice sheets depressed the land beneath them, causing surrounding areas to bulge upward. Now that the ice is gone, those bulges, the four bulges, are collapsing, slowly pulling coastlines like the US East Coast down toward the sea. Others are sudden. In subduction zones like the Pacific Northwest, centuries of tectonic stress can release in a single massive earthquake, dropping the coastline by meters in minutes and leaving behind eerie ghost forests of dead, saltwater-drowned trees. And some, entirely our fault. Pump too much groundwater from an aquifer, and the land above collapses into the emptied space. That's why parts of California's San Joaquin Valley have dropped by meters in less than a century. Houston has sunk more than 3 meters in places because of oil, gas, and water extraction. Even the weight of our cities, billions of tons of concrete and steel, can press the ground downward. The sea is closer than you think. All these types of sinking, from the deep, slow-motion loss of the craton beneath North America, to the collapse of post-Ice Age forebulges, to the rapid subsidence caused by human activity, share one dangerous consequence. They amplify the effects of rising seas. It's called relative sea level rise, when the ocean isn't just climbing higher, but the land beneath it is also sinking. It's a double hit. Imagine filling a bathtub while the floor it's sitting on is slowly caving in. The waterline seems to rise twice as fast, even if the faucet's flow stays the same. In parts of the US, this is exactly what's happening. Coastal regions like Norfolk, Virginia, Galveston, Texas, and parts of Louisiana are experiencing effective sea level rise 2 to 3 times faster than the global average. That means higher tides creeping further inland, storm surges hitting with greater reach, and nuisance flooding becoming a routine part of daily life. This sped-up flooding timeline drags billion-dollar damages decades closer. Infrastructure built for 50 years might last barely 20. Can we stop it? Stopping the deep hole under North America? Impossible. That's the slow heartbeat of the planet, playing out far below human reach. But surface subsidence? That's something we can manage, if we act. Tokyo did it. In the 1960s, parts of the city were sinking nearly 9 inches per year from groundwater pumping. Strict regulations, plus investment in surface water supplies, slowed it to less than half an inch a year. Urban planners can anchor skyscrapers to bedrock, build parks that double as flood reservoirs, and design infrastructure with differential sinking in mind. the deep lesson. The massive hole beneath North America isn't a hole at all. It's a reminder that our planet is alive and restless. That continents are not eternal, but works in progress. That ancient battles between plates can echo for millions of years, quietly reshaping the world we think is stable. The Farallon Plate may have vanished from the maps, but it hasn't vanished from history. It's still down there, locked in a slow-motion struggle with the heart of North America. And for now, it's winning. Drip by drip.